Welcome everyone. My name is Tomasz Pawlowski and I'm a Squish technical consultant at froglogic. I'm very happy to present at the Qt World Summit this year. During this short talk, I would like to talk about automated Qt GUI testing. I will focus on demonstrating a solution for a real cross-platform aspect of automated GUI testing. Let me show you a plan for this talk. So first I will briefly discuss different perspectives you can look at GUI test automation tools and their capabilities. You can consider, when looking at the automated GUI testing tool, you may consider a list of supported UI technologies, its verification and validation capabilities. You may also consider tool ability to recognize UI controls. Finally, you may consider the list of supported platforms and the ability to design fully cross-platform tests. So during this talk, I'll focus on the last aspect, which is cross-platform testing. I have the example Qt application, which is compiled for both Windows desktop and also which is deployed on the remote device which runs on Linux for ARM. First, I will design a few automated GUI tests for the Qt application on Windows desktop. And then I will introduce a test configuration where the user can decide where the test should be executed. And after running the tests on a embedded device, I will adopt our tests so they are valid for both environments. But first, let's go back to discussing different capabilities that need to be considered when choosing GUI test automation tool. The very first criteria is its UI technology capabilities. With Squish GUI Tester, you can test applications built with the Qt toolkit. Squish recognizes Qt widgets, QML, and Qt quick controls. You can even automate interaction with embedded web content implemented using a Qt web engine. Additionally, you can automate applications built with various Java toolkits, web, and mobile. You can also test native Windows and Mac applications. Tests are designed to verify that the application works as expected. The GUI test automation tool should offer various verification types. So regardless of test scenario, you're able to verify the expected test outcome. The Squish GUI Tester allows users to verify object properties or to do a screenshot comparison. For complex objects, you can do visual verification of content, geometry, topology, and visual appearance. The newest additions to Squish verification capabilities are search image verification and OCR text verification. Before you can verify the UI control, you need to be able to recognize it. Squish GUI Tester supports multiple object recognition methods, including the default one, property object-based approach, but you also can go with image-based approach or even OCR text-based approach. Last but not least is the support of various platforms. The easiest to say is wherever you can run Qt application, you can also test it with Squish. This means support for desktop platforms like Windows, Mac OS, Linux, popular platforms for embedded systems like Linux on ARM or QNX, and for mobile platforms like Android and iOS. Each of the mentioned criteria deserves its own talk and demonstration. But in this session, I will focus on designing real cross-platform tests. We'll discuss the differences and common things between different platforms. The presented solution will include one test codebase that works on any platform. So let's start. So in the first step, we'll create a free test cases using Squish IDE. In the first one, we use object property verification, in the second one, screenshot verification, and in the third, image presence verification. I will use Squish IDE, and the first thing is to create a new test suite. The location is here for my test suite. I just need to provide a name. To select the toolkit, which will be Qt, I will select Python, to be precise, Python 3. I will choose catalog application as a default application under test for this test suite, and I click finish. Now I need to create the first test case, and I click the record button. My example application is started. So now I will, in the first test case, I will go to Gauges tab, and I will set the speed to some value, heating to some value, and will verify the discharge power value. So I will go verify object properties. I will pick my object for verification. I will search for the value, and I will add that to the verification. So we expect that the value is 19. I save insert verification, and I can click stop recording. So the first test case is created. Let's create the second test case, where we will do screenshot verification of the speed gauge. So again, I click the record button. Example application is started. I go to Gauges. I set a speed to some value. And now I will add a screenshot verification. And I need to pick the object for verification. It's a screenshot type verification. I click the checkbox. The object image is taken, and I save insert verifications. I'm done, so I click stop recording. Let me just rename this verification point. Speed gauge. Okay, and the third test case I will create will use the image presence functionality for Squish. So I click the record button. So I go to graphs, and here I have this wave being displayed. So I can add verify search image. My wave is selected here. I will just give it a name, wave PNG, and click insert verifications. And I click stop recording. Okay, so I have created 3 test cases. Each of them is a little bit different, but they interact with different UI controls, and they also perform some verifications. Let's run all of them to verify if they work correctly. So I just click run the entire test suite from the Squish IDE. The first test case looks finished, it's passed. Second test case as well is passed, and the third test case is executed. It's also passed. You can take a look here at the test results, and all 3 test cases with different verifications have a pass status. We would like to be able to run our tests against the same application but running on an embedded device. So the main difference is the way Squish hooks into the application. For desktop applications that run locally, the most popular approach is to start the application for each test case by calling start application. For the application running on remote device, most of the time we attach to the application that is already running, and we call attach to application function. So our solution should handle this difference. We'll start by creating a configuration file for our tests where we store a setting for the target environment. So this is our project, the electric car, and here we have inside here is our test suite, but I already created a test conf for the project. I have introduced the target keyword that can be set to desktop or device. So let's set that to desktop for now. To make our solution more flexible, the configuration settings can be overwritten by Squish target environment variable. So we need to implement a solution that, based on this setting, the proper way of hooking to the application will be used. In this configuration file, we have set target is desktop. The first thing I will add to the global scripts, I'll add the framework directory, and now I will create here utils file. Inside this utils py, I will create a test configuration that will contain just a target for our test. I will make my test configuration global, so it can be accessed from other places, and while introduce the function that reads my configuration from the file. So here you can see that I'm using the config parser package. I read my configuration here from this file, and I read the target keyword, I read the value from that, and I also validate my configuration file. So if the target is not desktop or device, I will raise a value error exception saying that is incorrect value for the target keyword. My configuration is global, and I read my configuration here. So what I need to do is I would like that this configuration is read for every test case. So one of the things that Squish can offer is to use this init function, where I will just call read configuration. Here I will also go back to my first test case, and what I will do, I will call this global init function. I would like this global init function to be called automatically, so I will say that init function is located in utils package, and there is a init. We also need to import the utils package. Okay, so now this init function will be called every time the test case is started. I would like to call not start application. I would like to change that, and I would like to implement my own starting method. So I'll create a module AUT where I call start. So now let me create this module. And here I would like to add a start function. So basically what this function does, so we call that from the test case, and we are reading the target from the configuration, and if it's a desktop we call start application catalog, if it's device we attach to application. Those applications should be registered within our Squish server. Okay, so we call the AUT start, we need to import AUT. Let's run this test again to see if everything is fine. it is. I will modify all my free test cases. So now every test case is calling our start function, which depends on the configuration. Will either start application or are attached to already running application. Our current setting is that we are using the desktop application. So let's run all test cases from the test suite to verify that our solution didn't break the test execution on the desktop. First test case pass, second test case pass, and the third test case passes as well. Perfect. Now let's change the configuration setting that we run our test cases on the device. So in the configuration, I will change to the device. And where is this device that we run the test case? It's located on my desk here. It's the same application, just this device is used to run it, and the application is the same, but it runs on Linux. Application is already registered, so when I call attach to application, we should succeed. Let's run all our tests on this device. So the first test case passes, the second test case fails, the third test case failed. Okay, so now we need to take a look at our tests and the result, and why those tests failed on the device. So for sure, the object recognition based on properties and object property verification work on any platform without any changes. But all the visuals like screenshots VPs, image-based testing, layout verification are highly dependent on the screen size, resolution, and image rendering specifics. So they may differ on the target environment. Okay, so let's take a look at let's go back to the Squish IDE, and let's take a look at those failures here in the test case number 2. So this test case failed on the screenshot verification. Is I would like to implement my test to use different screenshot verification points for each platform. So let's say the original one that we have here will be our speed gauge. So let's duplicate those VPs here. And I would like to have one for desktop and one for device. Okay. I don't want to recreate this test case for the device, so I will just now call test VP speed gauge device. Run this test case again. It will fail, but I'll just choose the option use as expected result. Okay, so now I have a speed gauge on desktop and speed gauge on device. You see they are a little bit different. So basically my idea is that I will just call a function which will just verify if at least one of this verification point is passed. So I will create a verification module. Okay, and here I will put a function that will basically go through all lists of verification points and will pass if at least one of them is passed, and will fail if all of them are failed. I use this Squish feature called silent verifications, the setting here. So when I perform this verification, if there's a failure, I don't have any results. I need to handle the results by myself by logging pass or fail message. So I will just call this function from verifications. Instead of calling in my test case test VP, I will import verifications here. And I will call verifications screenshots VPs, and here I will provide a list of verification. At least one of the screenshot verification must pass for my test case to be successful. So let's run this test again on the device. And I have information that speed gauge device matched. Let's go back to the third test case where we call for the in the graphs tab for the wave to be present. This one failed. Okay, so for the third test case, I will do the solution a bit differently. I will now create a wave image for the device. I will put a breakpoint here. We'll run the test case. Test case will be executed until the breakpoint is reached. And now I will click the to record snippet. And I will now again verify search image. I will convert my wave image to the image group. So I'll click convert to group, and I will take a new image for this group from the device. I will call it wave on device and click insert verification and click stop recording and done with the test case. Now we have a wave, so let's copy that to the wave in the System Explorer. So now I have a wave directory, and inside there I will have two wave files. So you see there's a slightly difference between them, and I will name the first one wave desktop and wave device. So now I have in the search image, I have a directory called wave with two images. And what I will do, I will call just test image present wave. So basically this is built-in functionality to the image present that at least one of this file from this directory must match. So very similar to the previous test case, but you can see we have information verified, image wave occurrence 1 was found. We don't know now which one, but we are sure that at least one of them matched. Okay, so also for the image presence, we have a solution where we build a directory image group with different images for different environments. Okay, let's run all of our tests on the device and let's see if they pass. Okay, so all three our test cases are passed. Perfect. But now let's check if we didn't break tests for the desktop version of our application. Test configuration file, and now let's run our test case on the desktop. And let's run all of three our test cases. Now, okay, the first test case pass. The second test case will be much more interesting with the images. Also passed. And the third one with the image presence also passed. Perfect. So the next step can be to enhance the test configuration file to set the device, IP, and the port number. So during the test initialization, an attachable application will be automatically registered based on the provided data. So I have added to the test configuration those IP and the port number. Let's extend the utils. So our test configuration will now contain more information, target IP and port, and I will also extend the read configuration function to read all the data. So now you see we also read IP and the port, and we create a test configuration using those three values. We also need to change the AUT. So you see during the start we just attach to the application, but I would like to change that. If we use device, we read IP address and port of the device, and we call register attachable AUT function to register this green box device on the IP address and on the port. The function to register attachable AUTs is not a part of the Squish API, so we need to implement this function. So as you can see, this function is rather quick, short. So we take a Squish runner path. The Squish prefix environment variable is automatically set when you run the test. We use Squish runner and then Squish runner command to register our attachable green box. Let's now take a look at the configuration. So now we can easily, when we work with multiple devices, if we want to run our test case from the IDE, we can just change the IP address and our test will run on different device. There is no need to restart the IDE. The presented solution offers a convenient way to work on automated tests that can be run on multiple environments. So when working with the Squish IDE, you can easily modify entries in the test configuration file to set a target environment from desktop to different devices. When you run your test cases from the command line or from the CI tool of your choice, you can dynamically set environment variables and specify your target. For every test case, to sum up, initialize calls init function, which is global. This init function reads the configuration. In the configuration, we read the target, if it's a device or desktop, and we can also read device IP and device port number. And also every test case calls our start AUT function, which start application, if it's a desktop, target is desktop. If the target is device, we register the application, so there is no need to register attachable applications with different IP address, then automatically, and then we attach to the application. I also introduced the function in the verification modules to test different screenshots, and this function goes through the list, and if at least one of them passes, the verification passes. And also for the image-based verifications, I introduced the image group, where we also have different images for different environments if there is a need. Okay, so if there is more questions, I will be in the speaker's lounge for the next 30 minutes to discuss this solution, and thank you very much.